Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is inverse trigonometric functions. This is the second video on this topic. In the first video we gave the introduction to inverse trigonometric functions. In this video we will be focusing on NCERT solutions for exercise number 1. In the first problem, we need to find the principal value of sine inverse minus half. So we let y equal to sine inverse minus half, and we know that the principal values for sine inverse is between minus pi by 2 and pi by 2. So we write this as y lies between minus pi by 2 to pi by 2. This symbol is belongs to. So this can be written as sine y equal to minus half, and we know that sine 30 degrees or sine pi by 6 is equal to half. We can write this as sine y equal to sine of minus pi by 6. Sine of minus theta is minus sine theta. So we write this as y equal to minus pi by 6. This is the principal value of sine inverse minus half. In the second problem, we need to find the principal value of cos inverse root 3 by 2. So we let y equal to cos inverse root 3 by 2, where y belongs to 0 to pi. This we should remember for sine inverse, cos inverse, tan inverse. These are tabulated and generally given in table values which you should by heart. This can be written as cos y equal to root 3 by 2. And we know cos 30 is root 3 by 2, cos 30 is nothing but cos pi by 6. So we can write cos y equal to cos pi by 6. Comparing these two, we can write y equal to pi by 6, which is the principal value of cos inverse root 3 by 2. In the third problem, we need to find the principal value of cosec inverse 2. So we write y equal to cosec inverse 2, where y belongs to minus pi by 2 to pi by 2. So this can be written as cosec y equal to 2. We know that sine pi by 6 is half. So cosec pi by 6 is 2. So we can write this as cosec y equal to cosec pi by 6. Comparing these two, we can write y equal to pi by 6, which is the principal value of cosec inverse 2. In this problem, we need to find the principal value of tan inverse minus root 3. So we let y equal to tan inverse minus root 3. For the inverse tan function, we know the principal value is between minus pi by 2 to pi by 2. This equation can be written as tan y equal to minus root 3. And we know that tan 60 is tan pi by 3, which is equal to root 3. So we can write this as tan y equal to, replacing root 3 with tan pi by 3, tan of minus pi by 3. Comparing these two, we get y equal to minus pi by 3 is the principal value of tan inverse minus root 3. Find the principal value of cos inverse minus half. So we let y equal to cos inverse minus half, where y belongs to 0 to pi. This is the principal value of inverse cosine function. This we should remember. Now this can be written as cos y equal to minus half. So this value y is between 0 to pi. So it is either in first quadrant or second quadrant. Since cos is negative, it is in the second quadrant. So we can write this as cos pi minus theta equal to minus cos theta. We know that. So we substitute theta equal to pi by 3 or 60 degree, cos pi minus pi by 3 equal to minus cos pi by 3, which is minus half. Replacing minus half with cos pi minus pi by 3 here. So cos y will be cos pi minus pi by 3, which is equal to, this is equal to cos 2 pi by 3. Comparing these two, we get y equal to 2 pi by 3, which is the principal value of cos inverse minus half. Find the principal value of tan inverse minus 1. So we let y equal to tan inverse minus 1. So for tan inverse function, the principal values should be between minus pi by 2 to pi by 2. This can be written as tan y equal to minus 1. So tan y equal to minus tan by 4. Since tan of minus theta is minus tan theta. So comparing these two, we get y equal to minus pi by 4 as the principal value of tan inverse minus 1. Find the principal value of sec inverse 2 by root 3. We let y equal to sec inverse 2 by root 3. For secant function, we know the principal value lies between 0 and pi, where minus pi by 2. This means pi by 2 is not included in 0 to pi. So from this we can write sec y equal to 2 by root 3. We know that 2 by root 3 is sec pi by 6. Comparing these two, we get y equal to pi by 6 is the principal value of sec inverse 2 by root 3. Find the principal value of cot inverse root 3. We let y equal to cot inverse root 3. For cotangent function, y belongs to 0 to pi. Its principal values lies between 0 and pi. From this, we can write cot y equal to root 3. Root 3 is nothing but cot pi by 6. So comparing these two, y equal to pi by 6 is the principal value of cot inverse root 3. In this problem, we need to find the principal value of cos inverse minus 1 by root 2. So y equal to cos inverse minus 1 by root 2 we are equating, where y belongs to 0 to pi. So we can write cos y equal to minus 1 by root 2. Since it is a negative value and y is between 0 and pi, so it is in the second quadrant. So we can write this as cos minus pi minus theta as minus cos theta. So cos of pi minus pi by 4 equal to minus cos pi by 4, which is minus 1 by root 2. So we can write cos y equal to cos pi minus pi by 4, which is cos 3 pi by 4. Comparing these two, we get y equal to 3 pi by 4 as the principal value of cos inverse minus 1 by root 2. Find the principal value of cosec inverse minus root 2. So we let y equal to cosec inverse minus root 2. Y belongs to minus pi by 2 to pi by 2, excluding 0. So from this we can get cosec y equal to minus root 2, which is equal to minus cosec pi by 4. Comparing these two, y will be minus pi by 4 as the principal value of this trigonometric function. In this problem, we need to find the value of tan inverse 1 plus cos inverse minus half plus sin inverse minus half. The idea is first to get principal value of the first function, then the second, and then the third trigonometric function. So we let y equal to tan inverse 1, y belongs to minus pi by 2 to pi by 2. Using this, tan y equal to 1, y equal to pi by 4. So this is the principal value of the first tan inverse 1 function. Now we need to find principal value of these two. We have already seen in this video the principal value of cos inverse minus half is 2 pi by 3. Similarly, we have seen earlier the principal value of sin inverse minus half is minus pi by 6. Now we add all the principal values, or we substitute the principal values here. So we substitute the principal values for these functions, pi by 4 plus 2 pi by 3 minus pi by 6, and the result is 3 pi by 4. So this is the value of this function. Find the value of cos inverse half plus 2 sin inverse half. Again, we will find the principal value of this trigonometric function, inverse trigonometric function, and this inverse trigonometric. So let y1 equal to cos inverse half, where y1 is 0 to pi. So this we can write cos y1 equal to half. So y1 equal to pi by 3 is the principal value of this cos inverse half. So y2 equal to sin inverse half. Y2 belongs to minus pi by 2 to pi by 2. So this can be written as sin y2 equal to half. So y2 equal to pi by 6 is the principal value of sin inverse half. Now we substitute y1 and y2 in this equation. We substitute pi by 3 plus 2 into pi by 6, which is 2 pi by 3. This is the value of this inverse trigonometric function. This is a multi-objective question. If sin inverse x equal to y, then what are the ranges of y? So given sine inverse x equal to y, so we can write y equal to sine inverse x. Y or sine inverse varies between minus pi by 2 to pi by 2. So y is between minus pi by 2 to plus pi by 2. So option B is correct. We need to find the value of tan inverse root 3 minus x inverse minus 2. What is the value? A is given as pi, B is given as minus pi by 3, C is pi by 3, D is 2 pi by 3. So let y1 equal to tan inverse root 3, y1 belongs to minus pi by 2 to pi by 2 is the principal values of tangent function. From this we can write tan y1 equal to root 3. So y1 is pi by 3, which is the principal value of tan inverse root 3. Now we find for sec inverse minus 2. So let y2 equal to sec inverse minus 2. y2 will be 0 to pi excluding pi by 2. So from this we can write sec y2 equal to minus 2, and previously we have seen this will be lying in the second quadrant. Why it will be lying in the second quadrant? Because it is a negative value. So y2 will be pi minus pi by 3, which is 2 pi by 3. This we have seen here. Why we are subtracting with pi? In our previous problems we have seen this. So now we got the principal value of these two functions. We substitute here pi by 3 minus 2 pi by 3, which is minus pi by 3. So the option B is correct. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.